For this video, we will be talking about section 10.1, which is adding and subtracting polynomials. We are also going to be talking about naming polynomials based off of the degree and the number of terms. So we have quite a few vocab to talk about here right now. So a monomial, which we've actually already had this vocab once before, is a number, a variable, or a product of a real number and one or more variables. That could be an example of a number could be -3, a variable could be x, or a product of a real number and one or more variables. This could be like 7, x squared, y. That would all be considered a monomial. Remember, this means one term. Then we have a polynomial is a monomial or a sum of two or more monomials. So it just means multiple terms. Then we have a binomial, and this is the sum of two monomials, and a trinomial is the sum of three monomials. So basically, all you need to gather from this is that a monomial is one term, a polynomial is four or more terms, and then a binomial would be two terms, and a trinomial is three terms. We will use that information to name polynomials based off of the number of terms. Then we have to also name it based off of the degree of the polynomials. So the degree of a monomial, or the degree of one term, is the sum of all of the exponents of its variables. So notice the only thing that matters is variables. A non-zero constant term has a degree of 0. So that would be like the number 7 has a degree of 0 because there are no variables. Then it says, and this is another thing that's very important, 0 has no degree. So if I ever said, what's the degree of 0? You would literally write down no degree because it doesn't have a degree. Last thing we have here is the degree of a polynomial. Sorry, second to last thing we have here is the degree of a polynomial. So we have the degree of a monomial as you look at the exponents of its variables. That's how we figure out the degree of a monomial. Next, if you're looking at the degree of a polynomial, this is the greatest degree of any term in the polynomial. We will talk a lot more about that in that table down below. You can find the degree of a polynomial by finding the degree of each term, and then you have to pick the greatest one from all of those. Polynomials are named by their degree, and we will talk about all of those names once we get down to the table. The last thing we have here is standard form of a polynomial, and this is where the terms are written in order from greatest degree to least degree. We will talk about that at the bottom of this page. So let's go ahead and start talking about our table here, and I'm going to zoom in just a little bit more. So looking at the first row here, we have 7x plus 4. So when we're trying to find the degree of this polynomial, again, we have to look at each term individually. 7x is to the first power. So this has a degree of 1. 4 has a degree of 0. If you remember that from up above, a non-zero constant term has a degree of 0. So again, when we're figuring out the degree, all we care about is the exponents of the variables. That's it. Since x has an exponent of 1, 4 does not have any variables, so that's why it's 0. The highest degree would be 1, because 1 and 0, 1 would be higher. The name using the degree, we call this a linear polynomial. And then the number of terms, I see one term, two terms. So there are two terms. This would be a binomial, if you remember that from our vocab up above. So if I said, hey, name this polynomial 7x plus 4, you would tell me it is a linear binomial. On the second one here, I see an exponent of 2. So this has a degree of 2. There are no other terms, so that would be the highest degree there. We would name 2 a quadratic. And then I only see one term. So if it's one term, it's a monomial. And then on the next one, I see a degree of 3 for the first term, 2 for the second term, 1 for the third term, and 8 would have a degree of 0. So then the highest degree that I see is 3. So we would name it based off of the highest degree, the highest exponent that you see. So the name using the degree would be a cubic. And then I see 1, 2, 3, 4 terms. Remember, terms are separated by plus signs or minus signs. So I see 4 terms. And then remember from up above in that or in the vocab that we were talking about. A polynomial is just what we call 4 or more. I know the definition says 2 or more, but 2 technically has a specific name and 3 terms has a specific name. So then 4 or more we just call a polynomial because poly means many. And if I could spell, that would be awesome. Polynomial. There we go. Okay, and then on the next row, I see a degree of 4, a degree of 2, and a degree of 1. 4 would be the highest one, so then we call this quartic. And then I see 1, 2, 3 terms, and this would be an example of a trinomial. And then we have 5. 5 has no variables. Remember, that's how we find the degree, is the highest variable. Since this does not have any variables, this has a degree of 0. And again, we learned that from up above in the definition of the degree of a monomial. It says a non-zero constant, meaning any number but 0. A constant has a degree of 0. And actually, since it has a degree of 0, since it's just a number by itself, we would actually call this a constant. And then for the number of terms, I only see 1, so this would be a constant monomial. Now, the next one gets a little tricky because this one has no plus or minus signs. So this is technically a monomial. If you read the definition of the degree of a monomial, remember we have to add all of the exponents of all of the variables. So this technically has a 1 here and 4. If we add them together, that gives us 5. So this would have a degree of 5. So again, remember, we only add them if there are no plus or minus signs in between the terms. So if it's a monomial, you got to add them together. 5 would be called quintic. And this only has 1 term here, no plus or minus signs, so 1 would be a monomial. Now, something that we're going to take note of here, 3 over x can actually be rewritten as 3x to the negative first power. If you remember that from our last chapter when we had exponents, if we move things from the opposite side of the fraction bar, the exponent becomes the opposite sign of whatever it was. And typically we like to have positive exponents. If you also remember from 8.1, the definition of a monomial went a lot more in depth, and it actually said that you are not allowed to divide by a variable. So in this case, since we're dividing by a variable, we have a negative exponent. This is not a polynomial. And we would literally write that through this table. And then I actually like to just kind of cross out the rest of the table so that I don't fill anything else out, because even though it's not a polynomial, I'm not going to put that it's 2 terms and a binomial because it's not a polynomial to begin with. So we can't name it based off of the information for naming polynomials. So if I look at the next one, I see the 6th degree on this one, and this has a degree of 0. 6 is higher than 0, so we name it based off of the highest degree. You will notice that we have named 0 through 5 so far. Those have all have names. Anything 6 and above, we're just going to say it's that number degree. So 6th degree, 7th degree, 8th degree, 21st degree, whatever that number is, anything higher than 6, we just say it's that number with a degree. I see 2 terms here, so this would be 2. Basically, this is a binomial. And then the last one here, I see a negative exponent. That would make this 5 over x to the 3rd power. And again, remember, we're not allowed to divide by variables based off of the definition of a monomial. It is no longer a polynomial, so we would literally write not a polynomial. And I cross out the rest of the table so that I'm not tempted to fill any more out. So whenever we write not a polynomial, basically you're looking for, let me get a different color that I haven't used on either of those 2 sections. So you're looking for either negative exponents or variables on the bottom. Negative exponents or variables on the bottom. That's what makes it not a polynomial, just based off of the definition. And then I apologize, but for some reason, my last example did not make it onto this table, but we do have one more example on the front of these notes to talk about. So we have 8x squared y to the 5th plus xy. So this one looks slightly different than the ones that we've done so far in this table, whereas we still have 2 terms. So I still see this term right here, and then I have this term right here. So I'm going to go ahead and skip over here. We have 2 terms, therefore still making this a binomial. And then the other thing that we still have to make sure we pay attention to is what's the degree. So if you remember, again, earlier when we had the 3xy, we had to add the 1 and the 4 together because that was one term. So looking at, where is my laser pointer? Right here. Looking at this first term right here, 8x squared y to the 5th, we would add those exponents together. This would technically have a degree of 7. Then we have our xy. This is technically x to the 1st, y to the 1st, so this would have a degree of 2. So between 7 and 2, the 7 is higher, therefore making this a 7th degree binomial. That one tends to get a lot of questions because there's multiple variables there. So remember, when it's all one term, you do add them together. When it's multiple terms that are separated by a plus or a minus sign, you do not add them together. So that is it for the front side of the notes. Let's go ahead and go to page 2. Okay, back here on page 2 of our notes, we're going to write each polynomial in standard form. So if you remember from the front of our notes when we talked about all of the different vocab words, that standard form definition of a polynomial was the very last one of all of those bullet points. And this is when we write the polynomial in order from degree being the biggest to the smallest. So looking at number 1, I'm going to zoom in here just a little bit. And we're going to write the degree of each term before we actually put them in order. So looking at 6x squared, this has a degree of 2, 7 has a degree of 0, negative 9x to the 4th has a degree of 4, and then 8x cubed has a degree of 3. So then all I'm trying to do is put this in order from biggest degree to littlest degree. So this would make my negative 9x to the 4th go first. Then I would have my positive 8x cubed. And then this is technically a positive 6x squared, so plus 6x squared, and then my plus 7 would get brought down. This is going to be my answer in standard form because that goes in order from biggest degree to littlest degree. And then after that, it does want us to name it based off of the degree and the number of terms. So based off of the degree, again, is the highest degree. So with it being a degree of 4, we would call this a quartic. And then with there being 4 terms here, this would be a quartic polynomial. So this is just, again, using those words from the front of our notes from that table. So that would be our full answer for number 1. So putting it in standard form and then naming it based off of the degree and number of terms. Looking at number 2 here, 3y has a degree of 1, negative 4 has a degree of 0, and then negative y cubed has a degree of 3. Putting that in order from biggest to smallest would be negative y cubed plus 3y minus 4. There's my answer in standard form. So basically for standard form, we're just rearranging the polynomial and then again, naming it based off of its degree. Highest degree I see is 3, so this would be cubic. And then naming it based off of the number of terms, I see 3 of them, so this would be a cubic trinomial. And then looking at number 3, move this over just a little bit more. And then, looking at number 3, we see 7x and negative 11x. If we were to go through, 8 has a degree of 0, 7x has a degree of 1, negative 11x also has a degree of 1. Since there's 2 degrees of 1s, that actually makes them like terms. So we're going to combine those together really quick. We would get 8 minus 4x. And then from there, I still have to put it in the correct order. So then this would make negative 4x go first, plus 8. This would be my answer in standard form. Again, remember degrees, we're going from biggest to smallest. Negative 4x has a degree of 1, which is higher than a degree of 0 for the 8. So therefore, that's why that would go in that order. And then naming it again based off of its degree, that's technically x to the first power. So this would be linear. And then we have 2 terms here, negative 4x and 8 would make this a binomial. So then our official name for this polynomial would be a linear binomial. So you'll notice that that is it for just 1 through 3, putting it in standard form and then naming it based on its degree and the number of terms. Please, please, please notice the name of the degree comes first and then the number of terms comes second. So basically we're looking for a constant, linear, quadratic, cubic, quartic, quintic, 6th degree, on and on and on. And then the second name is always the nomial, whether that's a monomial, binomial, trinomial, or polynomial. Looking at 4 through 7, I'm going to move this down just a hair more. So 4 through 7, we are either adding polynomials or subtracting polynomials. You'll notice right here, when we are adding, we just group our like terms and then we add the coefficients. So looking at number 4, also it doesn't say it in your directions, but the expectation is that your answer is in standard form. So standard form, again, highest degree first. So when I go to add my like terms, I'm going to pay attention to which degree is the highest and then go from there. Looking at number 4, I see an exponent of 2. So that would make that my highest exponent or my highest degree. If I combine my like terms, I have 6x squared and 2x squared makes 8x squared. If you remember, when we are combining like terms, we do not multiply the exponents, subtract the exponents, add the exponents, whatever it may be, the exponents stay the same. So this is saying you have 6x squareds, you are adding 2 more x squareds. Therefore, you have 8 total x squareds. The x squared does not change. Then I see 3x and negative 6x. Notice I've underlined those twice to group them together. If I combine those together, I get a negative 3x. And then last but not least, I have a 7. So you can do one of two things. You can underline them with 3 underlines, or I typically just leave that last pair blank. But either way, that's my way of grouping them together. 7 and negative 4 makes a plus 3 here. This would be our final answer. So all of my like terms have been combined and it's in standard form. We go from 2 to 1 to 0, so we're good to go in order there. Now you'll notice that the directions here did not say to name it based off of degree and number of terms, but I do think it's good practice to continue naming it. Because this has a degree of 2, this would be a quadratic trinomial because there are 3 terms. Looking at number 5, again, we are still just adding the 2 parentheses together. So again, putting it in standard form, I see a degree of 4, but I don't see anything else that has a 4. So I'm just going to go ahead and bring that down because again, we want to go biggest to smallest for the exponents or the degree. Then I see an x cubed. I actually see 2 of them, so I'm going to underline them. We have 2x cubes plus 1 more. Remember, there's a hidden 1 there. Plus 1 more x cubed would give me 3x cubed. And then last but not least, bring down that negative 7x. There is nothing to combine with that one. If we were to name this, a degree of 4 would be quartic trinomial for 3 terms. Now, 6 and 7 are where things get a little bit different here. So looking at number 6, I see this negative in between. This is technically a negative 1. So in order to be able to combine like terms, we have to first distribute the negative 1. This only happens for subtracting. Obviously, with 4 and 5, when we were adding, there was no negative in between, no negative to distribute. If you were to distribute a positive 1, that would not change anything. It would be a waste of time. You could. You'd still get the same answer at the end. 6 and 7, though, with that negative in between the parentheses, we do have to distribute that to all 3 terms because you are subtracting all 3 of those terms from the first parenthesis. So first parenthesis is going to stay the exact same. I'm just going to bring everything down. That negative has no effect on the first parenthesis. But then when I distribute that to the second parenthesis, I would get a negative 9x cubed plus 7x squared, and then minus 3x. Then from here, I can go ahead and combine my like terms. So I see a degree of 3, which is my highest. So if I combine both of those together, I would get negative 8x cubed. Then I see x squared would be my next highest. So if I add those, I get plus 13x squared. And then last but not least, we have negative x and negative 3x makes negative 4x. And this would be my final answer. If we were to name this, a degree of 3 would be cubic, and then 3 terms makes this a trinomial. On number 7, again, same thing. Whoops. We do have a negative here again. So again, we have to distribute that. So I'm going to bring down that 5x cubed plus x squared minus 3x, and then distribute. We get negative 2x cubed, and then minus x squared. Combining our like terms, highest degree first, I see a degree of 3. If I combine those together, I get 3x cubed. Next highest degree would be squared. So then I'm going to underline both of those with 2 underlines. When I combine those together, they actually add up to 0. So I'm just going to completely cross them out. If you put 0x squared, not wrong, but technically it doesn't count as a term. And so therefore, if you were to count up your terms and then name it based off of the number of terms, you could potentially get that answer wrong. So anytime it adds up to 0, we're always going to cancel that out. We're never going to write anything for that. But then I do have to bring down that minus 3x. There was nothing to combine it with. So it just gets dropped down. If we were to name this one, this would be a cubic binomial. So now you'll notice the rest of these notes, it says on your own. So what I would like for you to do is hit pause on this video, try the last 8 on your own, and then we will come back together and we will see how you did. Okay, this is what you should have gotten for 8 through 15. So if you need to, make sure you hit pause, double check all of your answers, copy anything down that you need to, make corrections, whatever it may be. But that is it for your notes. So once you're done, you are good to go.